It's Dr. Dickenson. I'm going to be talking about why math pedagogy and why it's so important to think about integrating math pedagogy into other content areas. Well, I first want to share with you about as teachers, whether we are teaching elementary, middle school, or high school, we have an obligation to ensure our students are college and career ready. So think about some of the jobs that are now the top 20 jobs for 20 somethings. What do you notice about these professions? What are some skills from your subject specific areas that would really require them to do these professions well and to have entryway into these top 20 jobs? Yeah, you got it. A lot of them require math content knowledge and they require students to be fluent in mathematics and mathematical skills. So certainly math pedagogy is important, whether we're teaching social studies or Spanish. It's important for us to help support our students so they are career ready. So having an idea of integrating math across the curriculum, what does the research say? Well, we know that teaching math in isolation really does students a disservice. Math really needs to be connected with other subjects. It allows them support, it helps them in the future, it gets them college and career ready. And the NCTM, which is National Councils of Teaching Mathematics, also believe that integration of math into other subjects makes students think about the real world, which is the goal, right? It also helps students answer common questions. It develops critical thinking and problem solving. And certainly, there is a ton of brain research out there that points out how important it is for students to see those interconnections to help them make sense of what they're learning. So, this is really important to think about whether we are a single subject or a multiple subject teacher, how we can infuse and integrate subject specific content across the curriculum. And certainly, if you are a math teacher, you should be thinking about how you can build PE and art and social sciences into your curriculum as well. It's only going to give your students that real world application and real world lens, and it also helps support transfer of knowledge. All right. So we're going to talk a little bit about the Common Core mathematics and understanding the Common Core standards. There are three major features of math instruction. This was within the Common Core documents. First one is focus. So if this is a new space for you, you're going to see there are fewer topics, and this is really to allow students to go deeper in their learning. The second major feature is coherence. There is a strong push for interconnection into helping students see connections across the grades and to help them understand those connections as well as recognizing patterns. So, certainly, we can take the time to integrate math into other content areas and vice versa. And there's also an emphasis on rigor. Rigor calls for a strong command of math concepts, right? So we want to have that deep mastery learning, which requires real world understanding. It requires them to really develop skills to a level of fluency. And so when students can get to higher level math, that means that they have that strong command of those foundational skills. Just like we don't expect our single subject teachers to have to teach beginning reading, but yet if they have students that come in and they don't know how to read, you need to know what foundational skills they need so that you can support them. So let's talk about how to interpret a Common Core standard. So at the top, you have the domain. So this is, as you see at the top here, it's numbers and operations in base 10. And that is written as 3, which is the grade level, and BT, which is just abbreviated numbers and base 10. Then we have the big idea, which is use place value understanding and properties of operations to perform multi-digit arithmetic. This is part of the cluster, and there are 3 standards here. Standard 1 is using place value to understand to round whole numbers, etc. Standard 2 is fluently add and subtract within 1,000. And standard 3 is multiply one-digit whole numbers by multiples of 10. So essentially, the idea is that in order for students to be able to use place value understanding and properties of operations, they need to be able to do those 3 separate standards, okay? So when we think about each individual standard, we want to be able to unpack it. We want to know What do I need to explicitly teach? What skills and what knowledge? All right. And when we talk about coherence, you can see here those domains and how they're articulated across the grade level. So think at this bottom level here, we have measurement and data, which begins in kindergarten, and then it builds onto statistic and probability in sixth grade and through high school. Geometry is the one domain that starts in kindergarten and goes all the way through high school. You may be a big fan of geometry, and everybody loves geometry because you can build geometry concepts in other areas. Certainly, there is a ton of geometry in art, and maybe you're an art teacher and you've already thought about that. But certainly, there is also so much geometry in dance and just so much geometry in other subject areas that we can really be intentional with integrating. So, this is the idea of coherence in these specific domains that are articulated across the grade span. And then we have our standards for mathematical practice. There are 8 standards for mathematical practice. And essentially, this is a guide for us to think about how we can teach math to help build the habits of mind for our students to be successful in the concepts that we're teaching them. So there are 8 standards, and these are used across kindergarten through high school. And certainly, I have some other videos that you can watch and give you a little bit more understanding about what these standards mean and what they look like and what teachers must do so that students can actually develop these specific habits of mind. All right, so we want to think about the Common Core math, and it is a balanced approach. And what that means is that in your standards, you will see standards that focus on developing conceptual learning so students understand the underlying concepts. So think about something like multiplication. If I asked you, what is 3 times 2? You might say 3 times 2 is 6. But if I ask you to explain, how do you know 3 times 2 is 6? What makes 3 times 2 6? So I'm asking you more about that conceptual learning. And you might say, oh, I know that 3 groups of 2 make 6, and I can show you using physical manipulatives. Our students also need to develop procedural fluency, so things like the standard algorithm certainly come up. Things like adding and subtracting to 20 and having that fluency to do it very automatically. And then again, those 8 standards that I've already touched on. I just want to talk to you about math and academic achievement. As you know, in California, we have a large percentage of English language learners. And so when we think about English language learners, we all should think about how math achievement for English language learners can be a barrier for college and career as well. So, in essence, it's important for us to consider this. For the ELLs are 4 times as likely to drop out of high school. That's an important thing to consider because obviously we want our students to be successful. And we do have a large percentage of English language learners in California. But did you know that math achievement is the #1 predictor of school success? And that since 1996, the average math score for ELL 4th and 8th graders has been consistently lower than non-ELL peers. So helping break those barriers to higher math achievement is critical for our English language learners. And certainly when you think about language acquisition, you understand why it's so important to teach through that interdisciplinary lens, because our English language learners have to also learn that academic language, and to do so with mastery, we really need to teach for transfer. All right. In addition, I talked a little bit about college and career readiness earlier, but here's just some research showing that students who complete a mathematics course beyond the level of Algebra 2 more than double the odds of pursuing and completing post-secondary education. In California, out in the graduation rate, certainly having met those graduation requirements, which is a D or better in AG courses, they will be eligible to apply to the University of California and California State Schools with a C or better. So in order for our kiddos to meet those graduation requirements, we need to make sure that they are passing math. We need to make sure that they are successful in math. Um, and so this is really important for our students to consider, especially if we look at this graph on the right hand side. We know that English language learners are a larger represent low numbers in terms of pass rates, and a low number of students who are eligible to apply to the UC schools. So math is that gateway. Math is that piece of the puzzle that we really need to open up to support our kiddos, to make them feel confident, and to give them that mindset. So we talk about mindset, we talk about confidence, and teaching for transfer. Those are the three critical skills for math success. All right. Building on some of the research that's out from EdSource, which is a wonderful website. If you haven't checked that out, you can see that demographic breakdown and how that impacts the achievement gap. So for our Latino ELL Hispanic students, math achievement has historically been lower, especially as compared to white and Asian students. Again, there's the connections here with getting our students to have access to college and careers. They need to have math achievement. And the bar on left really articulates that those those percentages of students that are not exceeding, are not meeting those requirements for math. All right, so we talked about math achievement, talked about the value of content integration. Now let's take a look at some of these slides, and can you guess which subject area could use math in their content area? There may be more than one subject area. All right, so maybe you're looking at this infographic and say, yo no comprendo nada. ¿Quién es? Well, it's in Spanish. So you need to think about how we can share infographics to teach our students. And again, obviously, if they're looking at an infographic, they need to make sense out of it and interpret, what does this data mean? What does it represent? What are the fractional parts? How can I determine that from the whole? What would it be represented as fraction, decimal, or a percent? So that I can make sense out of this data. Another statistic, so you might be thinking, I teach Spanish, I don't teach math. Are you kidding me? Well, you could be teaching about culture and history and places in Spain, and sharing information about the demographics or the population, or quick facts. So there is so much math in that, right? All right. What about this image? Okay, you probably have recognized music notes, but did you know that music has fractions in it? It also has patterns. So building on math in a music classroom. All right. How about here? Maybe it's ringing a bell. Social studies, Roman Empire. But can you see the math connections? How long did someone live? What was the span of time that Julio Claudians ruled? How long was Augusta in around for? So just um, certainly getting them to see these connections requires some math skills. Okay. Maybe you thought art class here. And students are doing lines and symmetry, angles, measurement. How about here? Sorry for the bad pixelation. Yes, heart rate. That's physical education. You got it. All right, so we've had some few examples. I'm sure there's tons more that you could think about, from health to science to PE, even dance. Let's talk about those domains. There are some domains that we talked about. The first one is numbers and operations. This refers to mathematical skills such as arithmetic, reading and writing numbers, multiple and dividing, different types of numbers. So if you think that you might be able to make some connections in math, to numbers and operation. This is a good place to look at those standards. And again, I would check out something like Achieve the Core, where you can backwards map all of the standards. And we have algebra and algebraic thinking, which begins with seeing number patterns, understanding the meaning of addition and subtraction, multiplication and division, using symbols, and then moves on to, in high school, functions, equations, inequalities, etc. Okay, measurement and data. Yep, you got it. Telling time, length, volume, surface area, understanding tables and graphs, as well as statistic and probability. Geometry. This relates to analyzing 2 and 3-dimensional shapes, classifying shapes, writing proofs in high school, and using statistics and probabilities. You can see in high school, those domains tend to blend. All right, so now let's talk about unpacking standards in our math content area. Why do we unpack the standards? We want to know precisely what students should know, right? And that from there, we can build out specific observable and measurement terms. We can also link our standards directly to assessment, and this is key. If you are planning for doing something like the FTPA or the CalTPA, that is a win-win. You need to make sure that your standard that you've unpacked directly connects to those assessment, and then you can write those to as your learning outcomes or learning targets in your lessons and units. So, are you sure need to do this? Absolutely. Will I ever need to do this when I'm actually teaching? Yes. This is what makes for good teaching. It begins with planning, knowing your content area. In fact, there is so much research that shows that content matter expertise is one of the strongest predictors of students' academic achievement. So we need to begin by looking at our standards, by unpacking our standards, for developing our own content knowledge, and then planning lessons. So I'm a big fan of Robert Marzano when it comes to designing instruction. He has simplified this process into 4 questions. First question is, what do we want students to know and be able to do? Second question is, how will we know if they know it? There's your assessment. What will we do if they already know it? And what will we do if we teach it and they don't get it? Maybe we need to teach it differently, right? So that's your UDL piece there. And then those 4 essential questions, we begin with, what do we want students to know and be able to do? That's when we unpack our standards. How will we know if they know it? There's your assessment. What do we know if they already know it? We need to figure that out, right? Through our assessment-driven differentiation. And what will we do if we teach it and they don't get it? Formative assessment, intervention, and differentiation. So again, when we unpack our standards, what does that mean? This is the content, what the students will know. It can also be referred to as knowledge, not content, but it means the same thing. And what about skills? Well, you'll see skills that you need to explicitly teach, and that delineates what the students should be able to do. So knowledge is know, skills are do. Remember that unpacking is not just a creation of lists of nouns and verbs alone. Unpacking is not done after we create an activity, and it's not only for the courses you take in your teacher preparation program. So 3 big ideas. It will certainly help you in terms of thinking about what you need to teach, how you will teach it, what you will explicitly teach, and what you will overtly assess. I also find it really helpful for me as I unpack my standards. Think about some areas that might be really difficult for my students, some misconceptions they might have, some barriers to learning, maybe based on what I know about my students. All right, so step 1 is selecting that standard. Here's a standard that I've selected. It's geometry, 3rd grade. Partition shapes into parts with equal areas. Express the area of each part as a unit fraction of the whole. For example, partition a shape into 4 parts with equal area, and describe the area of each part as 1/4 of the area of the shape. So that's the standard. What I'm going to do is cut and paste the entire standard into each area. One side has content, which is the knowledge, the other side has skills. Now, I'll start with the skills column and just make those verbs a bold front. font. Notice that for skills, I've bolded partition, express, and partition and describe. Those are the verbs. Now what I'll do is divide the standard into statements. Partition shapes into parts with equal areas. Express the area of each part as a unit fraction of the whole. Now I'll examine those verbs. Are they observable? Can I observe partition? What would be something that I would see students do? What about the verb express? Is that also something that I could have my students show me? Let's think about how I might change those verbs into some verbs that are more observable. All right, notice now I'm saying students will draw partitions for shapes and they will label the area of each part. All right, hopefully that gives you a better understanding of how to unpack the standard, identify those skills, and then be able to modify those skills until I can see so observable outcomes. That will also help me when I'm starting to think about what assessments I might be giving. Now we're going to create a numbering system for each of these skills. This will help us when I'm backwards mapping my assessment. And now let's unpack the content or knowledge. Notice I just took that exact same standard and I identified those nouns or noun phrases that students will need to know from the standard. Voila, I've unpacked the standard. Remember, the standard still tells you what the students will know, your content or knowledge, and be able to do, which is the skills. Be mindful of some vague verbs that you may encounter. These verbs need to be translated to verbs that are observable, specific, and measurable. How will you measure use? You can't. So change those verbs. Here's some suggestions for translating vague verbs. Instead of understand, say explain or describe. Instead of use, say write, state, draw, or illustrate. Instead of know, say explain, describe, state the reasons for. Instead of express, you can say solve, write, state, or even sing. Remember, these are just not all-inclusive lists, but you should get the drift. All right, now we're going to link it to assessment. Start with unpack standards in each column. Describe how you assess each skill listed. And don't forget to look at that coding number because we need to match an assessment for each of those skills. So notice I took the skill of rounding whole numbers to the nearest 10, and my formative assessment will be a whiteboard response. I took the round whole numbers to the nearest 100 and have made it a Go Math rounding assessment to the nearest 10. Can also decide if I want to do something else, like a teacher-made quiz. You can make up your own assessments. Some of these, sometimes you'll get common assessments. You might get benchmark assessments from your district. You need to decide what you need based upon the standard and the requirements. And then we can link our standards to assessment and learner outcomes. This is kid-friendly outcomes and parent-friendly too. We can also start with an I can statement. So I can round numbers to the nearest 10. I can explain how to round numbers to the nearest 10 and 100. And then we want to make sure that we also include measurable outcomes. By the end of the unit, all students will round numbers to the nearest 10 as measured by 100% accuracy on the Go Math summative assessment. All right, the main ideas. Then we unpack our standards to know exactly what our students will know and be able to do. We always link our standards directly to the assessment, and we link our standards directly to learner outcomes. Well, that's all I have for you tonight. I hope you enjoyed my lecture on making math connections and unpacking math standards.